Good morning, good afternoon, or good evening, whichever is applicable to you, and thank you for joining us for today's webinar titled How to Do Almost Everything with IDCAMS. The Access Method Services Utility, IDCAMS, is probably the most important and one of the most commonly used applications on z/OS. Whether it's ordinary garden variety datasets or complex VSAM structures, aliases, and PDS or PDSEs, IDCAMS is involved in their creation, deletion, and access. The system programmer also relies on IDCAMS for managing catalogs, tape libraries, VSAM record level sharing, and more. Understanding IDCAMS and its amazingly wide variety of functions and features is a necessity for mainframe analysts from newbies to grizzled gurus. Today we'll take a look at IDCAMS, what it's used for, its features and controls, and the best ways to use it to get information and transform data. This presentation is sponsored by Precisely Software. Precisely is a recognized global leader in enterprise data integrity products for mainframe, mid-range, and distributed systems. For more information on Precisely, please visit precisely.com. Our speaker today is Principal Technology Architect Steve Pryor. Steve has more than 30 years' experience in storage management, design, and support, and speaks frequently at industry events. Prior to joining Precisely, Steve made important contributions at several mainframe software vendors, designing and implementing major products and components. At the end of the presentation, we will have a short Q&A session. Attendee microphones are muted for the presentation, but you may ask a question or request webinar assistance at any time through the Q&A interface. After the webinar, all registrants will receive a link to the slide deck and recording. Thank you again for joining us today. Take it away, Steve. Need to come up here on stage with me, Steve.
Okay, how about now?
There we go, perfect.
Great. Okay, good morning, everyone. This morning I want to talk about a utility that everybody's got. Every installation has IDCAMS because it is part of the z/OS operating system. But particularly for users coming from non-IBM environments, it's kind of mysterious. It is not quite clear, first of all, why it has such an off-the-wall name, and secondly, what sorts of things it can do. And in fact, it can do almost anything. There are really 3 or 4 major functions that we can talk about, and they're the sort of functions that you can do, that you have to do in almost every environment. You have to create files, you have to delete files, you have to copy files and move them. But we can do almost everything with IDCAMS. If the only tool you had was IDCAMS, you could still operate almost everything, do almost everything you need to do in a z/OS environment. And I'm going to sort of enlarge my screen here so I can move forward. Oops, and so we'll talk about IDCAMS, but first of all, we should probably talk about where we can find information about IDCAMS and what IDCAMS is, and again, why it has such an odd name. Well, one of the things you do have to get used to when you come to the IBM environment is odd program names. They tend not to be the sort of cutesy names like Jira and Splunk and things that you get in the open systems environment. They tend to be a little more esoteric, like IDCAMS or IDCAMS. Every major component of the IBM operating systems has a 3-letter identifier that sort of identifies all of the modules that belong to that system. IDC is used for catalog and for VSAM, and that's usually what you think about when you think IDCAMS. Is I'm creating VSAM datasets, I'm updating catalogs, but there's many other things that it can be used for. IGD is SMS, IEF is the base operating system. So every component of z/OS has a sort of a 3-character identifier that was more or less randomly named, most of which begin with I. Then the second half of this is simply access method services, or AMS. And so when you, an access method being in IBM terms, a means of reading and writing data. You can think of it as simply a means of doing I/O. There are several different access methods within the ZOS environment, BSAM and QSAM and VSAM, which is what we usually think of when we think of IDCAMS. The manuals, there's really one manual that kind of covers everything, and that's the access method services commands. It would be actually much easier to find if they just called it the IDCAMS manual, but it's access method services commands, or AMS commands. There's another manual called Managing Catalogs, for which I didn't actually put the number here, but the Managing Catalogs manual is sort of the other half of IDCAMS. IDCAMS itself is really meant to manipulate data sets and manipulate catalogs, but the more detailed use of the catalogs is in Managing Catalogs manual. And a couple of other manuals that are useful when we talk about metadata, or we talk about, that is, catalogs or VTOCs or VDSs, are the Using Datasets manual, which is when we talk about opening files and moving them and closing them and so on. And then there's an old red book, which is quite old, but it's still useful. VSAM Demystified, if we're talking about using IDCAMS to create VSAM datasets and copy into VSAM datasets, and we want to know about the internal structure, particularly of key sequence VSAM datasets, VSAM Demystified is a really useful red book, and you can find it on the Redbooks, IBM Redbooks site. But what I want to talk about today is what we can use IDCAMS for, practically speaking. And really, it falls into sort of two categories. We can obtain information about things, particularly about data sets. What kind of data set is this? What are its attributes? And particularly for VSAM data sets, any given data set can have many attributes. And when I say data sets, for those who are perhaps new to the IBM environment, data sets is IBM's rather scientific word for files. It's a data set. Data sets are kept track of in catalogs in the ZOS environment. Every single file, with rare exceptions, is cataloged. It belongs in its information about where that data set resides is kept in the catalog, same as if you remember the old days when you had card catalogs in a library. Every book in the library was cataloged. Every file, every data set in a ZOS environment is cataloged. And so if we want to manipulate the catalogs or get information from the catalogs, we're doing that with IDCAMS. It also contains information not only about data sets, but about volumes, the disk volumes that reside on the system, the tape volumes that reside on the system. It contains information about SMS. Usually when we're talking about obtaining information, we're talking about the listcat function of IDCAMS, and we'll go into that in some detail. There are other commands, though, like alter and like decollect if I want to get SMS information. The nice thing about IDCAMS is it's very consistent because it's really one program to do everything or to get information about everything. It has 20 or 30 functional commands that one can use to get information or to do something, to modify or change a data set, to create it, to copy it, to delete it. But while there are close to 20 IDCAMS commands, the parameters on the commands are consistent throughout IDCAMS. So in file and out file mean the same thing across all of the commands. Key name or key location, key position, and primary space and secondary space. All those things are consistent across the commands, making IDCAMS really pretty easy to use. So we can use it to obtain information. We can use it to modify things. We can create data sets. We can delete data sets. We can copy them. These are the main things that any engineer is going to do in any computer system. And we can do that with IDCAMS. Normally we think of IDCAMS as being for VSAM data sets, but it really works for for any type of data set, VSAM, non-VSAM, and of course the metadata structures we're talking about, the catalog. So VSAM itself has a very wide range of operation. It'll operate on data sets, or it'll operate on catalogs or catalog entries. And so it's designed to manipulate data and manipulate the data about data, the metadata. So we can use IDCAMS to create or update VSAM data sets. And when we do so, we very often will tell it what sort of VSAM data set we are interested in. Is it a key sequence data set, an entry sequence data set, a linear data set, and so on? Is it an alternate index, or the relatively new VSAM DB, VSAM database, which is designed to hold unstructured data like JSON data or object data, which we can define, which really in the IBM environment becomes a VSAM data set. Or we can use it to manipulate non-VSAM data sets. We can again create or delete or update sequential or partition data sets, or if what's now Broadcom, used to be Innovation Data Processing, has a number of you may have the Innovation Access Method or IAM data sets, which are really BDAM or direct access data sets that mimic VSAM data sets. Those can be manipulated with IDCAMS the same way you would a VSAM data set. So we can manipulate data sets, we can get information from data sets, and here we're primarily talking listcat. We can update information in the catalog entries. If we go to the right-hand side here, we can look at information or update information in the catalog itself. Each entry, and the word entry is important in IDCAMS, because when we talk about I want to identify a data set, or I want to identify an alias, or I want to identify a generation data group, what we're talking about is identifying a catalog entry name, and that is an entry in the catalog. A data set name, an item name, is referred to throughout the IDCAMS documentation as an entry name, because we have many different types of catalog entries. We have entries for aliases to data sets. We have entries for alternate indexes or clusters, types of VSAM data sets. We have entries for generation data groups. We have entries for tape volumes and tape libraries. The LibEnt and VolEnt entries are entries in a special catalog called the volcat catalog, or well, it's usually called sys1.volcat.vgeneral, the volcat catalog, which is a special catalog really only for system managed tape data sets, as opposed to the usual catalogs. So we think of the master catalog and its associated user catalogs. So IDCAMS can operate on the physical entities, the data sets, or it can operate on the metadata, the catalog entries, each of which resides only in the catalog, but tells us about things that reside out on the disk volumes. Yeah. So before we go any further, I want to do a little sort of level set on ZOS metadata structures for those who might not be familiar with them. They're actually pretty simple to understand, but the terminology, again, is a little different from what you find outside of the IBM world. In any computing system, we've got to have some sort of metadata structures that tell us where things are and what they look like. And in the ZOS environment, we're primarily talking, first of all, about the catalog, or the BCS, the basic catalog structure, which really is itself a VSAM data set. But the first place to look for a data set is the catalog. And the catalog contains primarily the name of the data set. It might be the name of some metadata structures like the VVDS, but it contains the data set name, and primarily the data set name and the volume serial number upon which the data set lives. And there's a whole bunch of other information that might be in the catalog, the alias information for generation data sets, what generations belong to the catalog, and so on. And in fact, within the BCS, you might have a couple of different types of what IBM refers to as sphere records, which are sort of composite records that tell us about types of data sets that have more than one component. And so there's a VSAM sphere record for every VSAM data set that tells us what's the base cluster name. If there is an alternate index associated with the base cluster, or if there are components, data component, index component, again, alternate index cluster path associated with a VSAM data set, this is all aggregated into what's called a sphere record. And so there are other records as well, but the sphere record is an aggregate that tells us about certain types of data sets that may have multiple components, including things like a GDG, a generation data group, which is a data structure unique to the IBM environment, where I'm creating the same data set over and over again, probably every day, but with a slightly different name, a generation number, so that I can recreate the same data set over, well, use the same naming convention over and over again, but create different data sets every day. And I've got to keep track of which ones I've created and where I am in the generation count. And that's all kept track of in a GDG sphere record. Now, the basic catalog structure of the BCS is associated with something that the catalog itself is a data set that resides out somewhere in a volume, but it's really something separate. It's a metadata structure in and of itself. On each volume, we have certain metadata structures that help us keep track of where data sets are and what they look like, what their attributes are. The one that from the IDCAMS point of view that's most important is probably the VVDS, the VSAM volume data set, which contains some information about the BCS and the VSAM volume data set itself, what catalogs it's related to. But what's most important about it are the VSAM volume records, the VVR, and the non-VSAM volume records. And the VVR within the VVDS relates the component names, because we might have a VSAM key sequence data set has a data component and an index component and may have other components. It's what relates the component names to the cluster name. And then there's other information kept in the VVR. The SMS class names, the data class, the management class, the storage class, those are also kept for non-VSAM data sets in the NVR, the non-VSAM volume record. So rather confusingly, the VSAM volume data set, the VVDS, contains information about non-VSAM data sets. When IBM came up with SMS, the non-VSAM volume record, or the NVR volume record, was invented so that we had a place to keep for each data set its SMS class names, the data class, the management class, storage class. And then there are two other structures that are related to things that IDCAMS does: the VTOC, the volume table of contents, which exists on every volume, of course, and has control blocks called DSEBs that tell us for each data set, where does it reside on the volume? What are its extents? What are its physical locations in the volume? And then finally, there's a VTOC index that is just what it sounds like. It's an index into the VTOC, but that's unrelated to IDCAMS. That's actually managed by a separate system programmer utility called ICKDSF, or dataset functions. But IDCAMS is going to manipulate data, first of all, on the volume. It's going to manipulate data that is pointed to by DSCBs, the data sets and their extents. It's going to manipulate the metadata when we create or delete or alter a VSAM record or non-VSAM record. We change its data class, we change its storage class, or we write data into it, or we delete it. We're going to update the VSAM volume data set, the VVDS, and the catalog itself. So we have these metadata structures that allow us to know what's on the volume and allow us to keep track of what the data sets look like. And the way we do that, the way we access and alter the data and the metadata is with IDCAMS. And we can invoke IDCAMS in a couple of different ways. I tend to think of it as a batch program, but really it's invoked from almost anywhere. You can call it as a utility. You can, within your program, invoke IDCAMS to do things like, again, create VSAM datasets or create non-VSAM datasets or alter entries in the catalog to change perhaps an expiration date or things like that. But it can be invoked in batch, which is probably more typically where it's invoked. It can be invoked from a program. It can be invoked via TSO command. I can issue a TSO command to say define cluster or delete dataset. And so ultimately, whether it's from batch or whether it's from a program or whether it's from a TSO command, ultimately SVC 26, the supervisor call instruction gets invoked. The catalog locate SVC gets invoked. We call it the catalog locate SVC, and it's primarily used for listcat to return information from the catalog, from those metadata structures we just looked at, to return that information to the program, to IDCAMS. But it's actually SVC 26 is a really wide-ranging SVC. It will do not only it will not only list information from the catalog, but ultimately when I do a define cluster or I do a define alias or any sort of define or create command to create tape catalog entries, all of that is done via SVC 26, via a very large and very complicated parameter list, which IBM never really documented, but is used by most of the vendors. But eventually they did document part of it, the catalog search interface, which is again documented in the IDCAMS manual, that will allow you to retrieve information from the catalog programmatically, saying, I want this information about the data set. I want to know its extents. I want to know its SMS classes. I want to know its encryption key label. All that information that's kept in the metadata repositories in the catalog, in the VVDS, is accessible through the catalog search interface. Basically, the catalog search interface can be used to get the same information you would get back with listcat. And it's actually, you can actually invoke the catalog search interface with Rex, and there are some examples in Sys1 Samplide. The thing you can't use the catalog search interface for is to actually create things, to do defines or to do alters and things like that. It can be done via SVC 26, but that's not documented. So what do we need to do to invoke IDCAMS? Well, if we're doing it from a TSO command, we just issued the TSO command, but ultimately we need sysin control statements, we need a sysin DD, and we need control statements. And we said, as we said, there's about 20 of them that tell IDCAMS what it is we want to do. Do I want to delete? Do I want to create? Do I want to alter? And then there's some other data sets that are usually required. We usually, if we're doing to create something, or if we're doing a copy, we'll need an input and an output data set. And those are usually referenced by an in file or in data set, depending on whether we want to specify the DD name or the data set name. An in file or in data set, an out file or out data set. And then confusingly, for some functions, there's also a file parameter as opposed to in file or out file. In file tends to be used when I am doing either I want the output of IDCAMS to go to a file rather than sysprint, or when I'm doing some sort of manipulation of metadata on a volume, I use a file DD to point to that volume if I want to update a VVR and that sort of thing. Okay, so we'll talk briefly about the control statements and kind of take a look at each of them. There are two flavors of control statements within IDCAMS. There's the modal control statements, or what the manual refers to as modal control statements, that control the flow of operations. That is, there are the if-then-else statements that say if some condition, then either continue or quit. Or set the condition code. They don't really do anything to data. The important control statements are the functional control statements that allow us to obtain information and display it. And primarily there we're talking about listcat, but there are others. We want to print the contents of a data set. We want to display the SMS information with decollect, or if we want to validate certain structures, we want to validate that the components of a VSAM data set are consistent. We want to validate that the catalog is correct. We can do a diagnose or examine or a verify or look at the sharing data sets. But primarily on the functional control statements, the one we'll use most often is probably listcat, because we're just getting information back from the catalog. There are also functional control statements that allow us to actually do something with data sets, to create data sets or copy them or to somehow change them in some way. There are a lot of these allocate for non-VSAM data sets, but primarily the define control statement is what one thinks of when one's dealing with IDCAMS. And primarily, probably the most common use of IDCAMS is to define VSAM clusters. But there are many other things we can define, and we can also alter them. And one of the nice things, as we said about IDCAMS, is that all of the parameters across the program are consistent. So if I define something and I give it certain attributes like primary space and secondary space and encryption key label and various other things, I can actually alter any of those by using the same parameter and the alter control statement. So I don't have to learn different parameters for each control statement. But probably of the modal control statements besides listcat, the big three are define, delete, obviously to delete any data set I'm interested in, and repro is really the VSAM copy utility. There are other copy utilities you can use in the system, of course, the sort and so on, but repro is probably the one that is certainly for IDCAMS is the one that's the one that you think of that's most commonly used. Okay, so just to talk briefly about the modal control statements. They provide flow of control. This is if then else, cancel, and set, really, to set the condition code. So we can do an if then else statement, and that is typically used for do I want to continue on, or do I want to do something based on the condition code. And the modal control statements look at the condition code of the last functional command that was executed. So if I've done deletes and defines and listcats, and I might come down to an if then else statement that says if the highest condition code so far, max CC, is 0, then maybe I want to do something. And so there's a do end. If I want to listcat a data set, if I want to print the data set, all within this do end clause, or if the highest condition code I ever encountered so far was non-zero, then I want to do something else. I can do an else do. I can say I can set the ultimate condition code. I can set the highest condition code I've seen so far to 12, and then cancel, and the job will end with return code 12. So cancel obviously will end the processing. I can say set either max condition code, that is set the highest possible condition code of any of the preceding steps, or I just want to set the most recent condition code. So if I want to create a data set and I don't want to get an error, I might initially put in a modal command or a functional command, delete some data set, and immediately follow that with a modal command to say, set the last condition code to 0, because even if the data set didn't exist, I don't want a non-zero return code. So if I attempt to delete the data set, it fails because the data set's already been deleted. Then I can override the non-zero return code I would get by saying, set the last condition code to 0. So the modal commands control the flow of operations, but it's the functional commands that allow us to really accomplish something with IDCAMS. And as we saw, there are plenty of these. There's about 20 altogether, but the 4 that people tend to use are listcat to display the catalog entry for a data set, or display a catalog entry that perhaps isn't related to a data set. Maybe it's an alias entry, or maybe it's a GDG base definition, or maybe it's a page space. But we can do a listcat on any entry in the catalog. And if we want to display the data set catalog, the actual contents of a data set, then there's a print statement, which is, again, it's pretty simple. There's nothing very sophisticated. If you want to do more sophisticated functions, then you can use something like the sort or any other utility, string sort MFX or any other utility to do more sophisticated selection and printing, but we can use the print statement in IDCAMS just to display the dataset contents. Probably listcat being probably the most common, and then next to that, probably define to create a VSAM dataset or allocate to create a non-VSAM dataset, or there are many other things we can define. We can define a non-VSAM catalog entry without actually creating a dataset. We can define alternate indexes over VSAM datasets. We can define path entries, many things we can define. So define or allocate will create either a dataset or just a catalog entry, depending on what it is you're defining. Repro is a really simple command in terms of its number of parameters, but it's what one is probably the most commonly used copy utility in ZOS. And it's just really, it takes an input, copies it to output. There's nothing terribly sophisticated about it other than being able to maybe skip a certain number of records or copy ranges of records. But repro is the all-purpose copy utility within IDCAMS. And then, of course, IDCAMS delete is used for everything to delete any sort of data set or any sort of catalog entry. And it will delete, it used to be that one had to specify the fully qualified name of the data set to delete, but nowadays IDCAMS has been enhanced, maybe it was probably 10 years ago now, which is recent by IBM standards, to delete using a mask. So we can do mask deletions and hopefully successfully delete a large number of data sets, and hopefully they're the data sets you intended to delete. Yeah, so we'll talk just briefly about each of these catalog entry types. Listcat is, again, probably the most common use of IDCAMS to display the contents of a catalog, to display the entries, or what are referred to as catalog entries. We're looking at the card catalog, we're looking at the individual cards. Listcat entries, and I can specify multiple entry names, and if I want, I can specify the entry type. I really, perhaps I'm only interested in key sequence data sets, or I'm only interested in non-VSAM data sets, or I'm only interested in GDG entries. So I can display the entry, I can specify one or more entry names, which might be a mask, and I can specify a high-level qualifier or some number of high-level qualifiers, but the masking is rather limited in listcat. It's probably the oldest, probably one of the oldest control statements in the entire IBM inventory. And so listcat, I have to tell it what entries I'm interested in or what qualifier level I'm interested in. If I issue this under TSO, it'll be automatically prefixed. So if I want to issue a listcat under TSO, I need to put the name in quotes, and if I don't want the TSO prefix appended to it or prepended to it. And then normally the output of listcat would go to sysprint, but I may want to put it to an output data set. And this is particularly useful if I'm generating a whole bunch of information, which I can then post-process with something like Rex, because the thing about the listcat output is it's fixed. It rarely changes, and so, but we can get a great deal of information by masking the listcat entry names, and we can get a whole bunch of information back, and particularly if we say listcat all, which says give me everything, then we generate a large amount of information. It's often useful to specify out file, put it in an output data set, and then post-process that output data set with Rex or some other utility like that. There's only a certain amount of selectivity I can specify on the listcat control statement. I can say listcat name, and it'll give me nothing but the dataset name and the catalog in which that name exists. So that's useful for all I'm interested in is name. But there are several other sort of levels of information I can get. It starts with just name. If I'm interested in a little bit more than name, I can specify listcat entry name history, which will give me the dataset owner, the creation and expiration dates, and the SMS class names, but nothing else. If I'm interested just in the volume information, it'll tell me the volumes and device types. For VSAM datasets, if I specify allocation, it will tell me for the data and index component, what volumes the data set resides on, where the extents are. There's since the selectivity isn't really very large, unless you only need something like the data set names. Do these data sets exist? Most cases, you just specify listcat all. So we can specify, again, this just gives us for each entry name or name mask in the catalog some information. In fact, if you say all, give me all the information for that entry name, which for VSAM datasets can be quite a bit. And if I'm doing a lot of VSAM datasets, or I want to list the entire tape volume catalog, then I might want to put it to an output dataset that I can process later. And so, just to take an example, and I'm not going to do this live. I have some jobs I could run to do this live, but it's everybody I hope is at least somewhat familiar with listcat output, and if you're not, this is the sort of thing you want to run. I can run a listcat entry, and it's a generic entry. I have an asterisk as the middle qualifier. For listcat, that's about the limit of the generic entries I can do. I can listcat a single. I can specify an asterisk for a single qualifier, but I can't do much else. We talk about delete. We can do a lot more masking, but listcat is kind of an old command. If I really want to do more sophisticated masking, I can run a program to use the catalog search interface to do more sophisticated dataset name masking. If I'm just interested in the SMS information and the expiration dates, I can say history. But probably more, I'm usually more interested in specifying all, which says for this, in this case, a VSAM dataset, tell me about not only the dataset, but not only the cluster, but the components, the volumes in which it resides, the individual extents of those volumes, what's the high allocated RBA, the high used RBA, all of that information. And the last listcat here is a listcat for all of the tape volumes that might exist on the system. And because there's a separate catalog, the volcat catalog, for the tape volumes on the system, which is something different than the tape management system, which also keeps track of tape volumes on the system. But the SMS managed tape volumes in the system are also kept track of in a special catalog, the volcat catalog, where every volume is prefixed with a V. So if I want to list all of the volumes in the volcat catalog, I can say listcat volume entries, V asterisk, and put the output to an output file. And then I can go and process that output file because it may be rather large. So listcat is probably the most common tool one might use because you're often getting information. I want information for about a particular data set or a number of data sets. Probably second most commonly used is the define control statement. And the nice thing about define is when I define a data set, I might have any number of attributes that I can specify for the data set. Is it a linear data set? Is it a KSDS? Is it an RRDS? How many generations should I specify? What volume serial number? What's the related data set name? But I have a single command to do all of these things. I can define an alias. I can define an alternate index over a VSAM key sequence data set. I can define the VSAM key sequence data set itself with define cluster. But I use the same set of operands, the same set of attributes for the define command and for the alter command. So really I have one command to rule them all here, define. Depending, obviously some attributes make sense, in some cases and others don't. If I'm defining a cluster, then I want to specify the component names. If I'm defining a non-VSAM data set, then that doesn't make any sense. I can define a user catalog or a master catalog. I can create a tape library entry. I can create, instead of define for a non-VSAM data set, I do have to use allocate. And so some of the entries that I might be defining are catalog entries only. I can define an alias. That's just an entry in the catalog. It doesn't alter the data set. I can define a generation data group. Again, that's just an entry in the catalog. So some of the defines will create catalog entries. Some of them will actually create data sets, like define cluster. And when we talk about define cluster, this is very often what we're probably the most common use of IDCAMS, where define a VSAM cluster with a name and some other keywords, and then optionally we can specify the name of the data component and the name of the index component and other keywords to override defaults. One of the nice things about IDCAMS is, of course, it provides you with some, for the most part, pretty good defaults. So we have attributes when we do a defined cluster that tell us things like what type of data set is it? Is it a key sequence data set, a relative record data set? How big is it? How many tracks? How many cylinders? How much free space? What does it look like? What are its data class and management class and storage class? Should I model it off of another data set? If you're using VSAM data sets, you might have to specify the VSAM record level sharing data sets. If this data set is to be shared, well, of course, defined cluster is only for VSAM data sets. You might have to specify the record level sharing attributes if you want to share that data set for multiple applications opening it for output at the same time. Then you're going to need a log stream ID and log file information and so on. And so there are some attributes from there. There's lots and lots of attributes on a defined cluster, but very often, for the most part, you're going to take the defaults on the defined statement. I might define other things. I might define a generation data group, which is a catalog entry only. And again, it's a unique to IBM thing where I define a catalog entry that allows me to create a similarly named data set over and over again, where only the last qualifier changes, only the generation number changes. And so define GDG will create me the sphere record, which we talked about, for the GDG base entry, including a generation table within the sphere that says these are the generations that are active. So I might create a generation data group that can contain up to 255 generations, or nowadays I can contain up to 999 generations if I say extended. And as those generation data sets are created, which is done outside of IDCAMS, might be done here, for example, by program IFBR14, I'll create generation 1 and generation 2 and generation 3. All of those, as they are created, are added to the generation table in the sphere record. Because GDGs, particularly SMS managed GDGs, when they are created, one of the things that IBM did when they created SMS back in 1989, for SMS managed data sets, they are cataloged at the beginning of the step and not at the end of the step. Well, for GDGs, it works a little bit differently. We have to catalog the data set at the beginning of the step, but we really don't know how many generations we're going to create until the end of the step. So generation data sets initially get cataloged when they are created with a flag in the catalog entry that says it's deferred. I've created the generation data set, but it's not part of the generation table. At the end of the step, all of those deferred generations are made active. They are rolled into the sphere record. Or if I've created generation 99 and I've only allowed for the creation of 98 generations in the generation table, then generation 1 rolls off. And so a generation data set can have an entry in the catalog that's outside of the sphere record, because it could be in deferred status or rolled off status. That is, it's not within the generation table. So I've got multiple different types of catalog entries for generation data groups. But when I define the generation data group, again, it's a variation on the define command. We've got define cluster, we've got define alias, we've got define non-VSAM. We want to define a generation data group. We have to give it the name, how many generations we want, is it extended or non-extended, that is, can I use 999 generations, and what to do when the generation count exceeds the number of allowed generations. Do I get rid of all of them? Do I scratch generations that are rolled off? How do I access it? First in, first out, last in, first out. All of this on defined cluster. So we can do lots and lots. As we can see, there are, as we said, about 20 different commands that we can do lots of things with in IDCAMS. We can create VSAM datasets. We can create GDGs. We can create non-VSAM datasets. And this is in this case, they simply took what was the TSO command, the TSO allocate command, and allows you to execute it in IDCAMS. So we can say allocate a particular data set, and if I'm in this case, if I'm using the allocate command and I don't want my TSO prefix prepended to the data set, I have to say no prefix, or I can just put the data set name in quotes. Allocate the data set given the storage class and the primary and secondary space and the type of space, the same syntax as the TSO allocate command, but I can do it under IDCAMS. And then again, I may want an alias name, so I have a define. I can define an alias to any number of things. Like usually one thinks of defining aliases to user catalogs, but I can define an alias to a particular data set, again, with define, just by using the relate operand on define alias. So we can define clusters and VSAM clusters, non-VSAM data sets, and generation data groups. And once we've got things created, well, maybe we want to copy them somewhere. And so typically that's the repro command. We'll copy typically all of the records, but you may want to copy only a certain range of records. By default, you can optionally overlay the target, or you might be copying, well, you can overlay the target or not overlay the target. The default is not overlay the target. Repro, there's also a variation of repro where I might not be copying user data or application data. I might be merging catalogs together. I might be merging user catalogs together. I might be merging tape volume entries together. And so there is a variation of repro where I add mergecat or volcat to it if I'm copying catalogs and manipulating catalog data. But usually repro is simply taking from the input, which is referenced by an infiler in dataset, and possibly some filtering criteria. There's not a lot of filtering criteria. I can say I want to skip some number of input records, or depending on the format, I want to copy from some key or from some relative record number, starting with that. I can also encrypt or decrypt, and I can use repro to encrypt or decrypt a particular data set using a particular key. So I can specify the key in here, or the key label. And I want to do it for maybe many different data sets. So I can specify, and the same as I could on listcat, I can specify one or more entry names or high-level qualifiers. But repro is really pretty simple. I can do it skipping however many records, counting however many records output, and either replace it or reuse as necessary if it's a VSAM data set. But it's a really simple means of copying data. There are many more sophisticated ways of copying data, and I always think about MFX, syncsort, or DFsort to copy data because it's very flexible as well. And it has much more, obviously, sorting and caping. There's no sorting capability within repro, but there's much more sophisticated sorting and copying capability within something like the sort. But if you just want a basic copy, repro is very simple to use.
Hey, Steve.
Yeah.
Quick question. Does repro stand for something, or is it short for something?
Well, reproduce is about the only thing I can think of. Yes. It simply reproduces the input out of the output. I think that's about probably the only thought that was given to that command. Most of the commands is pretty obvious what they do: define, cluster, alter, whatever the entry type is. Repro, I think probably the only thing that people thought about was I'm going to reproduce the input on the output. Okay, the other thing that we can do, and this is the really probably the most powerful or destructive, if you will, command that we can use in IDCAMS is delete. And as I said years ago, you had to specify every entry name. You could put these in parentheses as well. I'd want to delete this entry and this entry and this entry, and those entry names are typically dataset names, but they might be different entry. You could also specify the entry type. I am only interested in KSDSs. I'm only interested in GDG entries. I'm only interested in aliases. If you want to limit it in somewhat. And there's a couple of different ways of going about a delete. You specify an entry name or an entry name mask. And the masking on delete is a little bit more sophisticated than it is on listcat. Listcat really basically allows me to list kind of high-level qualifiers and maybe mask one or two qualifiers. If I specify mask or no mask, I have to specify mask because the default is no mask. Mask, if I specify mask, that allows me to use the catalog search interface filter, which is the sort of standard IBM filter that says an asterisk is either a qualifier or some number of characters, or a double asterisk being multiple qualifiers or multiple characters, and a percent being a single qualifier, single character. The only real restriction on the mask operand is the high-level qualifier has to be fully specified. But this allows me with the mask operand to delete large numbers of data sets. And when I'm doing that, I might want to overwrite the cluster with binary zeros by specifying erase. This is a little bit dangerous, particularly for large clusters. It may take a long time to erase. In fact, people have asked us, and we've added function in some of the single source storage management products to prevent the use of the erase operand, or to ignore the use of the erase operand, even if it's specified, so that you don't tie up a data set for a long period of time writing binary zeros over it. There's a force or no force operand saying I'm going to delete a data set or delete a type of catalog entry, perhaps a GDG, perhaps a user catalog, some large type of entry, perhaps a tape library. It might not be empty. Maybe there are still generations in the GDG. Maybe there are still entries in the tape library user catalog. If I really want to get rid of them all, I can say force. Purge or no purge allows me to ignore or not ignore an expiration date. And then there are some sort of other special purpose operands on delete, which are usually used by the system programmer to say things like, well, I want to delete the catalog entry, but I don't want to delete the data set itself. I can say delete no scratch, or I want to delete the catalog entry VVR, but I don't want to delete the DSCB, recovery or no recovery. So those are sort of special purpose. And again, I could write the output to a dataset name or DD name rather than sysprint. And maybe I want to apply this only to a special catalog. So delete's used commonly for everything, and I can do it under TSO. Again, the delete command really under TSO is the same as the IDCAMS command. It will allow me to invoke SVC26 and delete whatever sort of catalog entry I'm interested in deleting. And so just a couple of examples of the delete command. I might want to delete my data set, steve.test.ksds, or maybe this is a mask and I'm only interested in deleting things that are clusters or GDGs. If I want to get rid of a GDG, I can simply say delete that GDG, and that will delete the GDG base if it's empty. If I want to delete the GDG base and it's not empty, and then I will delete the GDG and all its associated generations, I can say GDG and force, and I want to delete it even if there are generations still active. The system programmer, as we said, might have occasion to delete just the catalog entry, even though the data set's out there, or maybe the data set's not out there and he wants to get rid of the dead catalog entry. I could say delete no scratch, which says delete the data set, but don't attempt to go out to the VTOC and actually remove it because it may not be there. Occasionally one runs into something called an orphan VVR, which is a VSAM, a record in the VVDS that doesn't actually point to a data set, or maybe points to a data set that's been deleted or been damaged in some way. And you can't create another data set with the same name until you get rid of this VVR that's left over in the VVDS. And so there's an operand on the delete command. I can say delete dataset name VVR, in which case I have to point to the volume that it resides on with the file operand. And that will allow me to delete a data set that has been partially deleted, that's damaged in some way. It doesn't have the catalog entry, but it does have an entry in the VVDS. And before I can create another data set with that name, I've got to delete the entry in the VVDS. And so I can do a delete VVR, or if it's a non-VSAM data set, delete NVR. There's a bunch of other functional control statements, but we've kind of tried to hit the big 3 or 4. Delete, listcat, alter is used. Alter is almost, the syntax of alter is almost identical. It's got all the same operands one might specify on a defined cluster or any other type of define, but I can change any individual attribute. I can change I can add volumes, candidate volumes to a data set. I can change almost any attribute of a data set via alter. There's a couple of others that are sort of less commonly used. Verify, one might run if there's been a failure to close a VSAM data set in some way. You can have trash left in the catalog entry. So it's not uncommon to run a verify after some, particularly as part of if a job step fails, there might be a verify step to make sure that VSAM data set's closed correctly. And then there are a couple that are typically, again, run to validate that things are kosher within the catalog itself. The examine and diagnose command will look at, examine command will look at an individual key sequence data set or individual catalog and make sure the key component matches the data component. And then diagnose is really used to make sure that the VSAM volume data sets match the BCSs, match the catalogs. And then finally, there are a few other functional control statements that people might not be familiar with. The tape control statements. We can create. There are 2 types of entries in the tape configuration database, or the TCDB, which is where SMS keeps track of the tape volumes. There are volume entries and there are library entries. And so we can create volume entries or create library entries. Normally, you never have to do that because that's done by ISMF. And so it's done by SMS itself. But you can manually manipulate the entries in the tape configuration database, which again is not the same thing as the tape management system. So we really have sort of overlapping responsibilities for the tape management system. We have the tape management system itself. We have the SMS tape configuration database, or Volcat, and then usually there's also, of course, a tape inventory in the tape device itself, whether it's the EMC DLM or the IBM TF7700 or whatever it is. It has its own inventory of which volumes and which libraries exist. There's a couple of others that are related to the catalogs and to building alternate indexes. There's the build index command, which will actually load the alternate index for a VSAM dataset with data. And then there's the rather complicated export and import commands, which you would use when you're moving catalogs about or backing catalogs up and restoring them. And they get a little bit involved as to if you're merging catalogs or backing catalogs up and restoring. This export and import, export disconnect, import connect, all have to do with manipulating the catalogs themselves. And so they're really system programmable functions. And then finally, the last one that is often a system programmer function, but anybody can really run it if you've got authority, is decollect. It's really not as well known because IBM provides it in typical IBM fashion. They provide a really good means of collecting information, but not a means of displaying it. So decollect, IDCAMS decollect command will get information from SMS, either from the volumes or from the storage group definitions or from the MCDS or the BCDS, and write it out to a data set, which can then be input to some sort of reporting application, Rex or whatever it might be. And I think we're just about out of time, but I think I'm almost at the last slide. There are a couple of IDCAMS errors. When you do get IDCAMS errors, you will typically get, for a list cat, you'll typically get an IDC 3009I, which is the result of SVC 26. And so there's a return code and a reason code, which you can look up in the IBM messages manual. They're usually easy to find. There's also something called the subfunction information, the SFI field, which is a 4-byte field that you can look up usually for an SMS error that in the SMS diagnosis reference that will tell you about the details of an SMS error that you get as part of IDC 3009I. And then there's a repro. Usually the error is an IEC 161. There's something wrong with the data set, usually when you're trying to open it or close it. And so those are the typical errors that one gets within if you're running IDCAMS at all. So finally, I want to talk about next month's webinar. Next month, we'll be talking about the ACS routines. We'll talk about testing the ACS routines, good practices for the ACS routines. Again, our specialty really is storage management. We do like to talk about that. I will be, as far as I know, at Share Pittsburgh on August 16 to 20, so you can come by and visit us at the Precisely booth. And we do try and write storage management articles for the Precisely blog. And so if you're interested in those, there's information. You can look at the blog articles there and select the mainframe category. I'll open, I guess we can stay open for a couple of minutes if there are any any questions we might want to ask. And so, Ray, I'll turn it back over to you. And anybody, if you've got questions, please let me know. And this webinar, everybody will get a link to the recording and the slide deck. So thank you.
All right. Yep. Thank you, Steve. Currently, no questions outstanding. So we would like to again thank everybody for attending today, and we'll see you at the next one. And you can always send us questions. Steve, you don't have your email address on here, but yeah, you can always send us questions.
It's pretty easy. It's steve.pryor@precisely.com.
And again, thanks everybody for joining. We will see you at the next one.